So we continue the discussion on various system properties. As I have stated that the concepts of the definitions and all those are that way simple. In fact, we did not discuss it in the beginning because that if it is there in the first module. But if we start with properties, then it happens so that the discussion becomes somewhat less interested for the students. So we discussed about the systems, considering the actual systems, various examples, and now we are just making ourselves aware of these fundamentals. As I had already stated that the classical things are already available to you, so the purpose of our lectures is to just make them simple in understanding. So if this happens that one sequence generates one output sequence, other sequence generates other output sequence, then if I apply another sequence which is a linear combination of these two sequences, then the output which I must obtain must also be a linear combination of these two individual outputs. So we can take some example. I am sure that there are few enthusiastic students amongst you who might have tried for various things, and based on that we can check whether the property of linearity is fulfilled or not fulfilled. As very clearly informed, we have input sequence xn and an output sequence y. Xn is given to a system and yn is obtained. Then we discussed that yn is weighted sum, but that what we discussed in first many sessions was actually, it means now there is some problem when we make the thing simple. So what we discussed till now are linear and time invariant systems. Now we are, when we started I did not tell you what is linear, what is time invariant. We discussed something which is a normal system. Now I will tell what is linear, but there can be other system like non-linear. So xn is input, y is output, and we discussed that y is some combination of current and past inputs. But that is not necessarily the only thing which we can have. There can be one system which you can easily implement using computer. Y is equal to xn square plus half xn minus 1. Xn square plus half xn minus 1. This can be a system. Now, or to start with, we can also simply have yn is equal to root xn, or you can simply have xn square only, that's all. So either this or this is simpler to take example. So this, whether it is linear, whether this system is linear, and we can very easily check where we can have a system that let there be xn starts with 1, x1 and 2, 3, let there be x2n, 4, 5, 7, 9, then what will be y1n? y1n would be, we can say this system, xn square, so 1, 4, 9. What will be y2n? y2n would be 25, 49, 81. Now I generate another signal x3n. I make it simple x1n plus x2n. I can add a x1n plus b x2n. I keep n and b as same. So x3n is 6, 9 and 12. I apply this to the system. So what would y3n? y3n would be 36, 81, 144. Right. So listen very carefully. I am taking a very simple example to inform you about the non-linear nature of the system. When x1 is applied, I get y1n. When x2 is applied, I get y2n. When I apply x3n, which is x1n plus h2n, I get y3n. As this. What is y1n plus y2n? y1n plus y2n is equal to 26, 53, 90. And this is not equal to y3n. Hence the system is not linear. If x1n produces y1n, x2n produces y2n, if I have a sequence which I generate using linear combination of x1n and x2n, that is ax1n plus bx2n, that is 2x1n plus 3x2n, can be x3n. If I apply x3n to the system, then the system will generate y3n. And if the system is linear, then when linear combination of two or more, when linear combination of inputs is applied to the system, then the output is same linear combination of output sequences which I would have got by individually applying the inputs. मराठीत सांगतो, जर दोन वेगवेगळ्या इनपुटचं लिनियर कॉम्बिनेशन जर का सिस्टमला दिलं तर सिस्टमचं आउटपुट जे येईल ते जर सिस्टम लिनियर असेल तर इनपुटचं ज्या प्रमाणात लिनियर कॉम्बिनेशन आहे त्याच प्रमाणात इंडिव्हिज्युअल आउटपुटचं लिनियर कॉम्बिनेशन असतं. इफ दॅट मॅचेस then the system is linear. If that doesn't match, the system is non-linear. The system is non-linear. Is the idea clear? So that is a system which is not linear in this case. So this is one property. In fact, what I would like to suggest is that you don't waste much of your time if you find it is not so easy to understand. You try your level best. But in normal case, we are considering the linear time invariant systems only. Just like the rules for left-hand drive, the rules for left-hand drive of a vehicle, left-hand drive vehicle. Then, if I am going to use right-hand drive vehicles only, in that case, I need not bother about those rules to a large extent. But you should be aware, you should try your level best to understand. So that is linear. Then there is one more thing called as time invariance. In some literature, I don't know whether you follow now multiple literatures as Google is available to you. It is also called as shift invariant. So linear time invariant, or that is now most common, but linear LSI is also shift invariant. Linear time invariant or linear shift invariant. Now suppose if I apply x1n and I obtain y1n from the system. I apply x1n and I obtain y1n. Then if I apply x2n, I generate x2n, let x2n be x1 n minus 1. Let x2n be x1 n minus 1. Then if I apply such x2n to the same system, then the system will generate y2n. System will generate y2n. And if the system is shift invariant, then y2n must be y1 of n minus 1. Or in general, this is, instead of 1, we can call it by any shift. Is by shifting by k samples. So this must be shifting by k samples. Means if there is system. To system I apply one input, I obtain one output. If I apply another input which I prepare by shifting the original input, that I prepare by shifting the original input, and I apply that, then I will obtain some output. Where the system is said to be time or shift invariant if shifted input applied results to this output shifted by same amount. Output shifted by same amount. If it happens, it is called as shift invariant or time invariant system. If it doesn't happen, then it is not time invariant, or also called as time variant system. Now, there can be different examples. Now, linearity is one property, time invariance is different property. So, linear, time invariant, linear, time variant, non-linear, time invariant, non-linear, time variant. So, there are 4 combinations. So, now what we can do is we will take one example of a system which is not time invariant, or which is a time variant system. So, I will generate a very simple system. We have xn, we have a system where I apply input xn and I obtain output yn, and the system equation what I can have is of different kind. We have a system equation yn is equal to x of 2n. Means how we can take an example. Xn is equal to 1, 2, 3, 4, 5. 1, 2, 5, 4, just in random value I am taking. So yn is equal to x of is 1, this is 5, this is 6, 7, 8, and this goes on like this. Yn is equal to x of 2n. Yn is equal to x of 2n. This is, we need to check whether this is time invariant or not. We need to check whether this system is time invariant or not time invariant. In that situation, we need to perform a check. What is a check? Generate, let this be x1n, then this be y1n. Now generate another sequence x2n by shifting x2n, let it be x1 of n minus 1, or n plus 1, either you can consider. Generate that, compute y2n, y1n is here, and try to establish whether y2n is equal to y1 of n minus 1. If it happens, it is shift invariant. In this case, I give it as a homework. It doesn't happen, so it is a system which is time variant system. The system which is time variant system. So it is linearity we discussed, time invariance we discussed. Now there are 2 more properties, that is causality. We will discuss causality. So I think it is very simple. Linearity property, time invariance property. Now we go for causality, then we take a break, and after that we go for stability. So causal, most of the students do a spelling mistake in it. They write it casual because they are so. So the property is causality. Causality, causality or the system is causal. Causal means what? If there is a cause-effect relationship, if there is a cause-effect relationship between input and output, then the system is said to be causal. And system is non-causal if cause-effect relationship doesn't exist between input and output. So it's very simple. I apply input, I obtain output xn, and I obtain output y. So yn depends on, so for a given, I give a simple example, not a classical definition, which you can check in the lecture of Professor Gadre or in the book. So then, while see, there are various properties. Normally, a good system which we work with, a good means it's not that other is bad, but a normal system which we work is linear, time invariant, causal and stable. Linear, time invariant, causal and stable, but these are 4 different properties and there can be 16 different combinations depending upon these 4 properties. Right? So, and while discussing one property, you need not be allergic about other properties. So, when we are discussing causality aspect, you need not stress, no, the time system should be linear, no, system should be time invariant. That is not required. So, causal means what? Cause-effect relationship. So, what we are having is, we have got xn and yn. So, yn is in general, yn is some function of xn. In general, yn is some function of xn. Yn, there is some equation which involves xn. What we discussed earlier was a linear combination, that is convolution summation hkx of n minus k for k running from 0 to infinity. That is one aspect we discussed by practical example. But in general, we can have a system yn is equal to, I'm writing xn square plus x of n minus 1 plus x of n plus 1. This is one of the system equations. This is one of the system equations. No problem. This is one of the system equations. So in this case, linearity is we are not bothered about. Now we are checking the property of causality, and when we are checking property of causality, yn, to compute current, listen very carefully, to compute current output, you can depend only on current and previous inputs. I am saying you can depend on, means it can be non-linear also. So if the expression of yn involves the term xn minus 1, xn minus 2 and so on, then it is called as a causal system. And if the expression involves the term of xn plus 1, xn plus 2, then it is non-causal. So it is now, whether non-causal is impossible, need not be. If it is real time, if the samples are coming real time, in that case the system has to be causal. But when we are having an image processing, where we are defining, generating something for a grail of a pixel, some kind of filtering, in that case you can take pixels on left hand side and pixels on right hand side. So in that case the index n is not related to time. So in that aspect we can have a non-causal system. So it is not that non-causal system is impossible. Only thing is that if we are having a real-time system, it has to be causal. So what is causality check? Yn should depend only on xn, n minus 1, n minus k for positive k. It can't depend on xn plus 1, xn plus 2. This is if it depends on current and previous inputs only, it is called as causal system. If it depends on current and previous and also future, it is non-causal. It is non-causal. Then there is one called as anti-causal. Just it's the reverse of causal. In that case, output depends only on current and future inputs and not on past input. But anti-causal is just one kind of definition. We normally don't encounter with such systems. So we encounter causal systems and non-causal systems. So is the idea clear? Causality, where there is a cause-effect relationship between input and output. Cause-effect relationship between input and output. Now, so linearity, time invariance, and then causality. So we discussed these three important properties. After discussing these three important properties, the most important property what we are going to discuss now is stability, and this is very important. Stability is very important property, and we need to elaborate in detail for this property. So as to what we mean by, we have system, we have input, we have output. Input sequence and output sequence, and we have system sequence. So what we mean by a stable system, on that front we will elaborate in the immediate next session. So you run the immediate next video for stability analysis. Thank you.